Okay, so moving on with the model of the atom, after Max Planck and Einstein and everyone was trying to figure out what's going on inside the atom, a scientist named Niels Bohr, who actually was working with Ernest Rutherford, came up with a new model of the atom that he thought explained why electrons did what they did. And he basically said that electrons move around the nucleus only in certain allowed circular orbits. So he kind of equated the atom to a solar system where each planet has a specific orbit that they follow around and around and around the sun. So the electrons are orbiting the nucleus. And as you can see here, he called the place where the electrons start the ground state, and when they're given energy, they can move to an excited state. And like we talked about in the previous video, to get back down to the ground state, they would have to lose energy in the form of a photon of light. So they absorb a quantum of energy, they release a photon of light. Now, according to Bohr, there are only specific places where an atom can have electrons in it, and he gave each orbit a number called the quantum number, and it's represented by the letter N. So the first orbit closest to the nucleus he called N equals 1, the second orbit N equals 2, so on and so forth. So in a hydrogen atom, since it only has one electron, its ground state would be in the N equals 1 orbit, and it can move up to other orbits depending on how much energy it absorbs. All right, so let's take a look at these energy levels. So the energy levels within an atom are similar to rungs of a ladder, meaning the electrons can be in an energy level, but they can't be between energy levels. You can stand on one rung of a ladder, but you can't stand in between. So the other thing that Bohr said is that as you get farther and farther from the nucleus, the energy levels are going to get closer and closer together, meaning it takes less energy to move from one energy level to the next within the atom. So here we go, energy level 1, that's going to be closest to the nucleus, and then 2, and then 3, and then 4, and you can see they're getting closer together the farther you get from the nucleus. Now, these particular colors represent the light that's emitted when electrons move from the third energy level down to the second, or the fourth down to the second, fifth to second, sixth to second. And these are the visible colors that we can see within the hydrogen atom when its electrons are moving around. And we're going to talk a lot more about those 4 colors and all of these transitions in class. Now, Bohr did a good job of explaining hydrogen. However, his model couldn't explain any of the other elements. It was only limited to hydrogen. So what that means is the electrons probably don't move in a circular orbit. It was good for hydrogen, but it doesn't really explain anything that has more than just one electron. So now scientists know, well, okay, we have limitations. We need to come up with a new model of the atom. So what happened is we get a guy named Erwin Schrödinger, and he came up with what's called the quantum mechanical model of the atom. And this is really what scientists believe is pretty accurate as to what's going on within the atom today. So Schrödinger basically said that rather than electrons moving in a certain path around the nucleus, that electrons are found in 3-dimensional spaces in the nucleus, 3-dimensional regions that he called atomic orbitals. So an orbit is a circular 2D thing. We're talking orbitals, which are 3-dimensional spaces within the atom. So that's what we're going to be dealing with for the rest of the chapter, is looking at these orbitals and what shape are they, and assigning electrons to the specific orbitals in a specific pattern, and using the periodic table to figure out what they look like. So Let's take a look at some of these orbitals that Schrödinger described in the quantum mechanical model of the atom. All right, so he basically said that each energy level, and remember that's kind of the same as Bohr, as we get further and further from the nucleus, our energy levels go up from n equals 1 to n equals 2, n equals 3, so on and so forth. So that part hasn't changed. The n is the same as what Bohr said. But Schrödinger said that in each level, there are a certain number of sub-levels. In the first energy level, there's only one sub-level. In the second, there are 2. In the third, there are 3. In the fourth, there are 4. So we're basically going to start digging down and defining what these specific spaces are for the electrons within the energy levels. Okay, so we want to look at each little sublevel, and each sublevel is going to represent a different orbital shape. So if the electron is in an S sublevel, okay, then it's going to be in a spherical shaped orbital. If the electron is in a P sublevel, it's going to be in this kind of dumbbell infinity shaped orbital. Remember, these are three-dimensional, okay? If it's in a D sublevel, then it's going to be in these kind of funky looking clover shaped sublevels. So the different sublevels represent different shapes of 3D spaces where the electrons are found. Okay. All right. Now, let's kind of summarize everything I just told you. All right, so in the first energy level, which is closest to the nucleus, there is only one sublevel, and it is an S sublevel. And we said that an S sublevel is what shape? Spherical. So there's only one in that first energy level. If we move to the second energy level, now we have 2 sublevels, 2 different types of orbitals. An S orbital, which is a sphere, and a P orbital, which is the dumbbell shape. Now, the S orbital only has one space for electrons. The P orbital actually has 3. So in the second energy level, we have 4 spaces for those electrons. The third energy level has 3 sublevels, S, P, and D. The S has 1 space, the P has 3, the D has 5 spaces. So in the third energy level, there are actually 9 spaces for electrons to be found. So you can kind of see the pattern that's developing. Now, what we're going to do in class is we're going to finish out the notes, and we're going to start looking at individual elements and assigning however many electrons they have to these particular sublevels, the S, the P, the D, and the F, if we get that far. And we're going to be assigning what energy level they're in as well. So we will do all the rest of the notes in class. Make sure you have your periodic table, and we will continue talking about electrons.